I'm Brian Risley, the president. I'm going to turn the mic over to John and let him introduce our speaker.
Okay. Welcome to the 24-25 Southwest Florida Astronomical Society Speaker Series. Tonight our speaker is Dr. Mario Motta. Mario is a well-known member of the Southwest Florida Astronomical Society. He is a medical doctor and a clinical professor of medicine at Tufts University and an active member of SUFAS. In addition to his medical career and involvement with the AMA, he is also well known as an astronomer. He has made numerous observations and publications to his credit, working with the American Association of Variable Star Observers, the Harvard-Smithsonian Center for Astrophysics, and MIT. In 2013, the International Astronomers Union named him an asteroid in his honor, asteroid 133537 Mario Motta. Mario is also the primary author on the AMA's recommendation on lighting and their current policy on human health effects of light pollution, which is the subject of his talk tonight. Please welcome me in welcoming Dr. Motta.
Too loud.
Testing? Okay, there it goes. All right, well, thank you. I appreciate the invite to give a presentation. Being amateur astronomers, I assume all of you want to see a dark sky so you can see deep sky objects and stars, right? So I'm not going to spend any time on that. The whole purpose of this is to give you reasons other than wanting to see the sky as to why we should have a dark sky. And primarily emphasis will be on the medical effects of the adverse human health effects of light polluted skies. There are many, and it's not as well known, although it's becoming an intense area of research. So let me jump right into it, see if this works. Here we go. Okay, those are my credentials. I'm a past president of the Massachusetts Medical Society. I was on the AMA Council on Science and Public Health for 8 years. And during that time, got several papers published through the AMA about, and they're now AMA policy advising cities as to what the best lighting practices are, primarily from a human health effect aspect, nothing to do with astronomy. Which raised the ire of some of the lighting industry, and I'll get into that later, although now they've come around. And I was a trustee at the AMA, so let me see. Here we go. Oops. A little tricky here. Come on. There we go. It's skipping a slide, but it's all right. I mean, dirty little secret, even though I talked about human health effects, that's the reason why I want dark sky as well. That's my homemade telescope, every part's homemade, ground all the optics. I gave a talk on that a while back, and I use it quite a bit. So that's what originally got me interested in light pollution. I've been giving talks about light pollution since the 80s, primarily from an astronomy standpoint. But then, skipping slides here, I think. No, okay. That's NGC 891 taken through that telescope. So let's talk about light pollution, how it affects human health. First of all, the most obvious is glare. How many people have a hard time driving at night these days with these super bright headlights? It's a very common problem, okay? It's not your eyes, it's bad engineers, okay? If the lights are designed properly, you won't have as much problem driving at night. If you don't believe me, go to a place that has proper lighting, like Tucson is a great example. You can drive down the street, you don't get the glare in your eye, you can see better, the streets are well lit, you can still see the Milky Way right above your head. So this is an absolutely doable problem. Unfortunately for us in Florida and North Carolina, Duke and Florida lighting are probably the two worst offenders in the entire country in terms of putting up bad lights. Maybe we can put a little bit of pressure on them. But the main reason is it interferes with circadian rhythms, and that's important because that causes a number of human health effects. And by doing that, it suppresses the immune system. It leads to some increased carcinomas, primarily endocrine-related carcinomas, such as breast, which was the first one discovered. And it can lead to mood and depression, obesity, cardiac events, and of course, we lose the night sky. Still not getting this. There we go. Okay, so like I said, I was interested in light pollution from an astronomical standpoint. I was going to do astrophysics and ended up in medicine. That's a whole nother talk and subject. But around 1987, Richard Stevens published this paper. He was an epidemiologist from University of Connecticut. And he's the first, and epidemiologists are a specialty that look at different facts and try to draw connections as to what may be causing cause and effect. So he's an epidemiologist, and he wrote this provocative paper in 1987 where he postulated that breast cancer increases if you have bad light pollution. And he was the first one to write that. I read that paper around 1990. I was a researcher with my group, and it piqued my interest as to another reason why we should have darker skies. Met him at a conference, and we've bonded with a lifelong friendship and partnership in a number of papers. Unfortunately, he died about 3 years ago, but he kind of started the field. There are now literally 50,000 papers on this subject in the world literature. So it's no longer a hypothesis. It's pretty well proven. And I'll show that. Maybe if I point it that way. Come on. There we go. This is a graph that was updated in 2010, I think it was, but this is what first piqued his interest. He noted that the United States was having, and Western Europe was having a marked increase in breast cancer rates. And everyone at the time thought, well, it must be bad food, toxins in the environment, something. They couldn't find out what. Meanwhile, he's looking at the rest of the world, looks at China, which is the most toxic water and air pollution, and said, it can't be that because in China, the rates are low. Furthermore, if you're of Chinese descent and you move to the United States, you rapidly rise to the same level as other North Americans. So he said there's something different about North America and countries like China, Middle Africa, other East Asian countries, which at the time had no light pollution at all. It finally dawned on him with other papers coming across of how light suppresses melatonin, and melatonin is an adjuvant to the immune system, that he figured that had to be the connection. And he postulated that. As it turns out, multiple papers later, including a Nobel Prize to the people who figured it out, proves that is correct. Light pollution here in Florida is pretty pervasive. We all live under these white areas, which is generally Bortle 6 to 8, whereas the Everglades is Bortle 2, huge difference. You know what I'm talking about. This is M81 through my scope. Kind of a delay on this. It keeps some kind of a delay. Hold on. I think I'm missing the slide here. Hold on. Trying to go back. Okay, let me go forward now one. Okay, so maybe I should just ask you to advance. I don't want to keep going back and forth all night. Maybe just the distance is too great for this. Go one slide forward. There we go. Stop there. So what is the problem? The problem is there's no such thing as a white LED. If you can figure out a way to make one, I guarantee you'll be richer than Elon Musk overnight, because everyone's been trying to make one for the last 20 years. What happened was in early 2000s, Akasaki Amano and Nakamura from Japan invented the blue LED. Okay, and for that they got the Nobel Prize in Physics in 2014 because it revolutionized lighting. And what you do is you take a blue LED and you coat it with phosphors. It absorbs the high energy blue and re-radiates it in the orange and green and red, which is what we need, whereas the blue actually is a problem, and we're going to talk about why. But they won the Nobel Prize for that, and it is a great invention. Next. Next slide.
Fine.
Okay, so after doing this for so many years, I can tell a 6,000 from a 2,700K LED. But when you see them side by side, it becomes obvious. The 6,000 is the intense blue. The 4,000 is still too much blue. To give you an example, 6,000K is about 40% blue, and 4,000K is 32 to 35% blue. Those are the lights when your headlights come at you that you want to go like this and you end up in an accident. 3,000 is tolerable. It's still very white. 2,700 is still white, but it only has about 15% blue and doesn't cause anywhere near as much damage and health effects as the others. Unfortunately for us in Florida, Florida Power and Light keeps putting up 4,000K, even though most of the rest of the country has gotten away from that. Go ahead. Next slide. And one of the reasons they keep telling you is, well, you need the color rendition for distance. Here you see up on the top different spectral lines of colors all the way down to 2700 is basically all the same. White is white. It's only when you get down to 1870K, which is the old high pressure sodium, that it starts to look orangey. But I ask a rhetorical question, and I asked this of the engineers who designed these lights. Do you really need to tell the difference between teal and blue 200 feet down the road? How does that make the driving safer? It doesn't. The whole purpose of a light is to see things, not to determine these slight shades in color, which they keep saying, well, bright lights are much better for that reason. Next slide. So here's a 2,700K light in a shopping center near my home. Colors are fine. Grass is green, the trees are green, the asphalt's black, the yellow on the building, okay? The color is fine with 2,700K. So that's the first slide many engineers will tell you. We need higher LED, CCT color temperature so you can distinguish color. Basically, that's not needed at all, okay? The reason why they want the high ones is they're cheaper to make. Next. So go back one.
I'll try.
You skipped one there. No, go back.
I'm trying.
Yeah, I know. That's why I mean, I can try with this, but. So many cities, when they first came out, LEDs around the 2010, 2012, you're going the wrong way. Way the wrong way. Go back. There you go. Next one. Right there. Stop there. Such as Queens, New York, one of the most light polluted places in the country, put up 4,000K lights primarily for energy efficiency, which is great. Perfect reason to use LED lights. Okay, the problem is you got to use the right LED lights. Back then, 4,000K was the only thing they had. They didn't know how to put the phosphors on properly to lower that CCT, the color correlated temperature. And so they put up these 4,000K lights, and immediately everyone in the city hated them. It's so harsh and blue that people felt like it was a prison atmosphere. And that's the universal reaction whenever you're exposed to 4,000K. So the average person tell you, well, do you want to live under 3,000K lights or 4,000K lights? It basically goes over your head. And for most city councils, they have no idea what the difference is. Once you're exposed to it, you immediately know what the difference is. And every place they put up, there's basically a citizen revolt. Next. So once they put those up, shining in everyone's windows, New York Times was flooded with complaints. City Hall was flooded with complaints. Eventually, they stopped putting them up, took them down, and put up 3,000K lights in New York City. If that's the reaction in one of the worst light polluted areas, can you imagine what it would be like in an area that's not so light polluted and you put up these horrendous lights that look like a prison light? Next. And it's not just New York City. Seattle put them up around 2012. 4 years ago, they decided with all endless complaints from citizens, they're taking them all down, and they're in a 3-year process of replacing them all with 3,000K in the main thoroughfares and 2,700 on the side streets. Davis, California put them up. Immediately, people hated them. They've demanded the city change them out. The city said, well, that's going to cost money. If you want this, you're going to have to raise yourself a tax increase. Never in a million years dreaming, that's what the citizens did. They actually voted to increase their taxes to get rid of those lights. That's how much they're hated. So don't let your local power station put up 4,000K lights, because you also will demand they get taken down. Monterey put up the wrong lights, 4,000K lights, and the town people actually sued their own city council to get rid of them and won. Next. Cities, and this is just a partial list, that require now 3,000K or lower, okay, in states with some light pollution laws. Next. And like I said, Seattle and Pittsburgh voted to completely change all their 4,000K lights and are putting up 3,000K lights. So why do we have this constant debate when citizens prefer warmer light at night? Okay, and part of the reason is initially the lighting companies bought basically warehouse full cheap lights from China, 4,000K lights, and they want to get rid of them. Now that most US cities refuse to take them, they're pawning them off on rural areas that don't know any better and sending them to Africa that don't know any better until they see them and then hate them. Next. This is Eagle Nebula I've taken. So I'm still an astronomer at heart. Next. So let's talk about why 4,000K lights are bad for you. The most obvious thing, of course, is the glare. You have to know something about what the human eye functions. So you have a lens that allows you to see up close or see at a distance, which works pretty well until you turn around 45, 50, and it becomes so thick that it doesn't accommodate well, and then you need reading glasses. The lens grows like an onion. It has new cells growing on the outside of it, the rest, kind of like tree rings, your entire life, which is a good design. We weren't designed to live to 100. We were designed to live to 50 after you regenerate yourself, and then you're supposed to die. So it's a problem. The problem is the lens has no blood vessels to bring nutrients to the center of the eye, none whatsoever. It absorbs all its nutrients, gets its oxygen through diffusion from the surrounding liquid. Because if the lens had blood vessels, of course, it would interfere with your vision. The problem is once it gets thick enough, again, usually in your 40s, the center doesn't get enough nutrients, so some of the cells start to die. And when they die, the body calcifies them because there's no way to get rid of that cell. So they calcify and then sit there, and that's what microcalcifications cause scatter, and eventually they'll coalesce and you end up with a cataract 20 years later. Next. And the older you are, the more scatter you get. The top slide on the right shows basically how much light entering the eye causes what we call disability glare. And by disability, it's not just glare like I'm getting from that light over there. It's glare to the point where you can't see well and you're likely to get in an accident. When you're 20 years old, it takes about 1,800 Lamberts of light and you get disability glare. When you're 60 years old, it takes 1/3 of that. So the older you are, the more scatter you get, the more you're disabled by bright lights. A person in the Netherlands, I Why didn't I have, I'm sorry, didn't put the reference there. I like to have references for everything so people know it's not just my opinion. Did a great study where he took human eyes and did cadavers on them. Now, the bottom is a log scale. So he just showed that the blue scatters 10 times more than the red. Again, it's a log scale. So just like the sun, when it's setting, turns red because the blue is scattered out. Same thing with the human eye, same physics are involved. So the blue scatters more. And so if you have a light that has a lot of blue in it, it's going to cause intense scatter in your eye. And that's the whole basis of the disability glare. Whereas if you had warmer lights, you get much less disability glare. Next. So on the left would be a 20-year-old if they looked at a glary light. On the right, it would be like most of us in the room, you wouldn't see a thing. Next. Here's George Fleener, who's right here in Bradenton, Florida, did this great experiment. Here's a typical security light that they sell at Home Depot and Lowe's that people think will make their home secure. Look at that light. Can you see anyone in the door right there? Next slide. There's someone standing there. These security lights actually blind you, and thieves love it. Basically, it gives them cover. So if you had a shield over that light, you'd still get the same amount of light on the ground, but you'd see a lot better. Here's a perfect example of that right here. Okay, the whole purpose of a light is for a photon to bounce off something and then go to your eye so you can see that object. If the light goes directly into your eye, all it does is cause glare and actually inhibits your vision of the surrounding area. Something some lighting engineers have no concept about, apparently. Next. Here's another good example from friends of mine in Quebec. Quebec has a law just like the US that where you have an on-ramp or an off-ramp, you got to have a light. Unfortunately, here it's an unshielded light. So you're traveling down the highway here at about 40, 50 miles an hour. Next. Here's a person there, just step forward 3 feet. So if you're going down the highway and you got one of these unsecurity lights that basically cause glare, there could be a moose, a stalled car, or a person in the road. You'd never see it because you're blinded because of that light. That's why these are unsafe lights. Next. Here's some examples that I've taken in Gloucester where they actually got a grant to put up these lights that were designed to look like whale lamp lights from Gloucester was founded in 1620, which was great in 1620 when it was a little little flame. But when you put a 200-watt high-pressure sodium in there, you got a problem. It's all glare, and there's very little light actually hits the ground. Next. They've since fixed these and we now have good light pollution law in Gloucester. But this is what it was like. The street is black. The lights are all going into people's windows. Next. This is what we got now, 19-watt LEDs. Okay, there's a 4-to-1 ratio. So if you had 60-watt high-pressure sodium, you should replace them with 15-watt LED lights. Unfortunately, at the time that these were put up, that was the lowest that they made. They now make 15 watts. Unfortunately, I don't see any of these in Florida. Okay, everything's grossly overlit here. Next. On the left is unshielded lights, but they did have, these are LED lights, but by just shielding them, look how much better it is. Next. You see better. The IAS, which is the Illuminating Engineering Society of North America, initially used to say, well, we need these lights for better safety and vision so you can see down the road. This is from Ron Gibbons from Virginia Tech. He did this study. Look into clear. That white is 6,000 K, and the red on the left is high pressure sodium with 3,500 K in between. You actually see better with the warmer lights down the road. Next. So brighter street lights actually cause more accidents. repeated studies, study after study. They don't prevent accidents. They probably do more harm than good. Here's the reference up top there. And the brighter lamps do not lead to an improvement in road safety. Now, next, I'll talk about the lighting company's response to this. At first, they were very antagonistic. Starting about 2 or 3 years ago, they've completely caved in. Now they're saying we should use the lights that the AMA said you should use 10 years ago. They've basically completely given in. Next. Except for Florida and North Carolina, surprisingly. So crime and road casualties. The study found no evidence, basically, of harmful effects if you just turn off the lights on either road collisions or crime. And I'll give you a couple more studies in that before I get into human health effects. Despite 14 years of data in 62 local authorities, this is from England, by the way, no convincing evidence of association between street lighting adaptations and road traffic collisions. Next. You won't find these studies from the lighting companies because I've given talks to lighting engineers all across the country, and I ask the same question each and every time. If you have any study that refutes anything of what I say and proves your point, give it to me, and I'll be happy to show it because I always like to give a fair and balanced report. 30 years of asking this, not one paper has ever been given to me because they don't have any, none whatsoever. Every study proves them wrong. So here's traffic collisions by switching off lights or part-time lighting. The effect is minimal, but if anything, it goes to actually safer streets if you cut down the lights. Next. Street lighting may enable rather than hinder street crime. Journal of Quantitative Criminology. They've looked for years to try to prove that more intense lighting prevents crime. Every study they do shows the exact opposite. So don't buy the lies from the lighting companies that you need this to protect yourself. It actually does the exact opposite. Next. If you ask, multiple studies have been done, and put these up, where they ask criminals, why did you choose this house instead of that house to break into? And invariably the answer comes down to, this house has all these bright lights and basically is a flashing sign that says, I got a lot of expensive stuff and I'm afraid of you. Please stay away. That's the houses they hit. Street lights on crime in Los Angeles. For every 0.1 increase in, for every 1% increase in LED lighting, you get a 0.1% increase in crime. And this was a huge study done in Los Angeles. Chicago Alley Lighting Project. Chicago, for people who've been there, have all these alleyways, and they said, well, we can stop crime if we put up all these light up all the alleyways. They got this huge government grant, spent several years lighting up all the alleyways with way too much bright lights, and they ran out of money 2/3 of the way through. Next. So criminal justice system, I think you went next. That's a crime, but it says the same thing. Thought there was another. Well, I'll just tell you what Chicago Alley Lighting Project. So they replaced 175,000 lights in the alleyways and lesser lit streets. What they found, and I think that's on the next slide. What they found, instead of proving that cut down crime, wherever they put up the lights in purple, the crime rate went up. Wherever they didn't touch the lights, the crime rate stayed the same or dropped. This was done by University of Chicago, their criminal justice degree program. So again, study after study after study proves the lighting company's wrong. So that's basically a huge lie. But people assume that more lights give you safety, so lighting companies don't want to change that. Next. This is my view of the Trifid. Next. So let's talk about specifically hormonal effects of bad lighting, which is the main point of my talk here, human health effects. First of all, you have a circadian rhythm, and about 10% of all your genes in your body are expressed based on this clock gene. That is, during the daytime, your genes are expressed differently than at nighttime when you're asleep. The whole point of sleep is to regenerate parts of your brain and parts of your body. And that's when most of the repair processes of your body occur. 10% of your genes are controlled by melatonin and the pineal gland. So if you put up bright lights, sleep in an area with lots of bright lights and you don't get a proper darkness, don't be surprised if you screw up 10% of your genetic expression that there's going to be a problem. And there is a problem. Next. Oh, before you change, actually, in 2003, this one receptor was discovered in the retina. We all know about our red, green, blue receptors, and we know about our dark, the rods and cones that we normally talk about to allow you to see in the dark. Those are 4 rods and cones that are expressed in vision, and those go directly from the eye to the back of the brain, which is your vision center. But in 2003, a different receptor called the IPRGC receptor was discovered that has nothing to do with vision. It doesn't go to the back of the brain. It goes to the pineal gland and what's called the reticulum center of the brain. What's its purpose? To wake you up, basically. So, and it noticed that it peaks at 479 nanometers, which is the color of the blue sky. So we evolved to live in caves and look at a blue sky to wake up. It's not going to, our evolution doesn't change because of 100 years of lighting. So what ends up happening is when the eye sees a blue sky, it sends a signal to shut down melatonin, and it sends a signal to the reticulum center to wake up the brain. Okay, and the opposite occurs. If you're lit up at night, then you don't get the proper rest and proper melatonin release that you're supposed to have in order to stay healthy. Next. And the pineal gland is extremely sensitive to 479. This was discovered specifically at 479 with 10, about roughly 10 to 20 nanometers on either side. In fact, a gentleman from Harvard recently wrote a book called The Light Doctor. It's a great book, by the way, if you want to look it up, where he determined that if you just block that narrow bit of blue, the rest of the blue can stay and you don't have the harmful effects. So one way to get around this is just put a filter in our lights so you don't let out that one wavelength. That's what's causing all the damage. And if you notice, 5,000 K lights, okay, have a huge peak at the 479. All that blue LED I showed you at the beginning basically peaks at 479, which is what causes all the damage. And if you get lower and lower, like 2,700 K, the amount of blue that sneaks through is much less. Next. So again, we have clock-controlled genes, and that's who wrote the book, The Light Doctor, Moorhead. And it's a great book. But Physiology of the Circadian Timing System, it's available now to read. It's very readable. Okay, next slide. So what is melatonin? Melatonin is a hormone produced in the pineal gland that basically regulates our day-night cycle. And you'll notice that when you travel across time zones, you kind of feel out of sorts. And that's because your circadian rhythm is now not in sync with your new time zone. But melatonin has a number of properties that are vital in human health. And when it's not working properly, you have increased mood and depression. It fights breast cancer. It shows human breast cancer in culture and prostate cancer. And I'll show you why that happens next. Next. Melatonin isn't just for sleep. It's an important part of your nighttime sleeping. When it circulates in your bloodstream, one of its most important, it does all these things. One of its most important functions is an adjuvant to the immune system. So our immune system is what protects us. It's not that a photon or a light, some light causes cancer. That's not what I'm saying. What I'm saying is the light suppresses melatonin, which is an adjuvant to the immune system. So what ends up happening is at night, if you get proper sleep in proper darkness, you have B cells that come out of your bone marrow, circulate looking for bad cells, tag them, T cells, which it's called T killer cells, which come from the thymus, circulate. Whatever's tagged, they kill. That's an important function. Every person in this room or listening here produces about 10 to 20 cancer cells every single day you've been alive. Okay, because we have, you're not the same person you were 2.5 months ago. Basically, all your cells have been replaced by constant divisions all day long. Your gut regenerates itself every 3 days. Your liver about once a month, your bone marrow about every 2 months. Without this regeneration, we would die. So if you think about it, we're dividing about, close to 10 billion cells a day. It's not surprising that it'll be an occasional mistake in the division. That's okay. Most of them will just die because they're not viable. But a certain percentage of them will be viable, they just can't be controlled. They continue to multiply and divide. That's the definition of a cancer. The T and B cells kill those cells, which is why you didn't die at your first year of life and why you live to an old age. As you get older, your immune system diminishes, which is why older people tend to get more cancers. But you don't have to speed up the process by destroying your melatonin production. Next. And if you think I'm exaggerating the fact, in 2017, the Nobel Prize in Medicine went to Hall, Rosbash, and Young, specifically because they discovered the whole mechanism of this in the late 2008, 2009, and they got the Nobel Prize for that. Next slide. You know, when the lighting companies give me grief on my talks, I say, they got the Nobel Prize for proving what I'm saying. Produce a paper that says I'm wrong and you're right. Here is the entire mechanism of melatonin. I'm not going to describe it. I just want you to know it's well worked out, and the Nobel Prize Committee thought so as well. Next. So a number of studies have exploded in recent years since the early days with Richard Stevens. There are 10,000 studies if you do a search for circadian rhythm, light and cancer. That's a lot of studies that prove what I'm saying to you is correct. The International Dark Sky has a database of 5,000 of these articles. You can download them yourself. It's very easy to use. Just get on their website. Next. This is my view of M51. And next. So in 2009, when I first got on the council, I was elected to be on the Council on Science and Public Health. First thing I did was put up a resolution that got passed, and the AMA policy remains that all streetlights should be shielded. And we're giving advice to the lighting companies, which of course, their attitude is, you're a bunch of doctors, leave us alone, we're the specialists, we're the engineers. Next. 2012, produced a paper with some of the best researchers in the world on the left-hand column there. In this case, I'm just a glorified editor because the other people actually did all the original research. But basically, it stated, it's a 36-page paper that summarized the world literature up to that point. The AMA has a system where everything we want to publish has to go through multiple academic institutions to say if there's any flaw in it, it's passed with flying colors, and got voted in as policy of the AMA. So it remains policy that we should use proper lighting. They're not saying don't use LEDs because they're energy efficient. They're saying use the right LEDs so you don't cause human health. Next. Lighting industry kind of just ignored that. Do you know who read that? And the Apple company with iPhones. If you notice, if you got an Apple phone, it turns warmer around 9 o'clock at night. That's because the Apple company read the AMA report and said, this is something we should put in our, so they developed a program where your Apple automatically goes to eliminates the blue late at night, which is a good thing. This is another article that, this is the first paper in the Journal of Cancer, which is the kind of the major US journal on cancer, on specifically describing all of this, and way back in 2013. Next. Then 2016 came around, and the lighting companies were ignoring the 2012 report and all the other papers that were coming out. So we published a report in 2016 that basically said you should use nothing above 3000 K. Next slide. And this remains AMA policy now. And all it said was use 3000 K or lower, okay? And all LED lighting should be properly shielded. Not exactly earth shattering. And it didn't say not to use LEDs. We should, because it cuts down on energy waste. The problem is when this came out, the lighting industry went ballistic because now cities were reading this and actually demanding the 3000 K lights. So they had these 4000 K lights that they couldn't get rid of anymore. They were furious. I kept some of these emails, but I actually got emails from like Siemens. I'll give you one good example. Siemens had a contract in 2016 they were about to sign with Chicago to replace all 370,000 lights, which were high pressure sodium at the time, with 4000 K lights. This came out. Someone gave it to the city council. I had nothing to do with it. They did their own research with multiple academic researchers and basically said, they're right. So they went back to Siemens and said, we want 3000 K lights. Siemens said, we don't have any. So they ripped up the contract and went with a different company. To this day, if you mention my name to anyone who works for Siemens, you're not going to get a very pleasant response because that cost them $1.1 billion in a contract. Okay, but what ends up happening is all these companies thought they were going to have a gold mine if they buy all these lights from China, store them in a warehouse, and palm them off across the country. They've managed to do that with some places, including Florida, but most states are now clamping down on this because the people hate them. Okay, it remains AMA policy, should be 3000 K or lower. If I was writing it today, it would be 2700 K or lower. Next. So this was a press release back in 2016, advising cities and mostly to advise physicians, be aware of this medical effect. And again, intense IES resistance. I even had a debate at Long Beach Lighting Conference in 2018, and I got more applause than the IES representative. Next. Here's a paper I just wrote that came out in November, and I gave it to Risley, and he said he's going to put it up. You can download it, or there's a link I can give you later. And if you read this, you can fall asleep now because everything I'm going to tell you is in that paper. But it's a summary of why we should have dark sky on from a human health effect. Next. And by the way, if you're a physician, any physicians here? No? Okay, if you read it, you can get 1 CME credit out of the 30 you need every year. Go ahead, next. So the IAS was fighting us tooth and nail until finally researcher after researcher convinced them, and they finally gave up the ghost in 2022. And this is the latest handbook that basically says everything the AMA was saying 10 years ago. So they've capitulated, although there's some diehards within the IAS that don't want to believe it. But their latest handbook says to use AMA guidance, basically. Well, they don't say AMA guidance, they say use 3000 K or lower and fully shield them. The problem with many city councils, they'll hire a lighting engineer for advice. And lighting engineers, let me put it this way, I'm a cardiologist. Would you trust a cardiologist who read nothing new for 30 years? I hope you wouldn't, right? I'm always trying to keep up with the latest, so I know the latest research. The problem with lighting engineers is they buy this thing once they get their degree and start doing projects and never buy another one. So a lot of lighting engineers will stand up in a city council and say, my handbook says 4,000 K lights are perfectly fine. My response to that is say, what year was that published? Oh, 2002. Okay, maybe you should get the latest one, which says that's all completely wrong. So remember that if that ever happens to you in a council meeting. Next. So breast cancer epidemic. Now, let me start off by saying 40% of breast cancers are from the BRCA gene. That's a genetic defect that many women do have, and 40% of the breast cancers are from that. That has nothing to do with what I'm talking about. But of the 60% that are remaining, this is a problem. So 1970, 68,000 cases of breast cancer. By 2014, 232,000 cases of breast cancer. What accounts for that such dramatic rise? Correcting for population increase, that's a 4-fold increase in breast cancer rates. It's now 6-fold increase. Next. And it's primarily premenopausal women, by the way. So there's voluminous breast cancer data now that basically women who sleep with light at night in their bedroom have 5 times the basal rate of breast cancer. Okay, night lights are great for kids. Don't use it if you're an adult. With the introduction of blue LEDs, 4% increase in breast cancer in premenopausal women and a 2% increase in GI cancers. Next. That's per year, by the way. So way back in his original paper, Richard Stevens predicted the following. If his hypothesis was correct, shift workers who constantly changing their circadian rhythm would be at higher risk. Blind women would be at lower risk, including twins. Lighted bedrooms at night increase risk, and long sleep lowers risk. Every one of those have been proven with literally hundreds of papers. Those are now true statements, no longer hypothesis. Next. And here is, I'll just give one example. I can't give you all the studies, but here is one. I don't know how they found so many women, but they went out and searched for twins, twin females, one of which had a vision impairment and one of which could see properly. And they studied them for 20 years. In the United States, if you were the one who could see compared to your twin sister who was blind, you were nearly two times the rate of getting a breast cancer. Sweden, Finland, Norway did their own studies, and those were the rates in those countries. So I'm not saying blind yourself, but there's something to learn from this. Next. Here is one of my favorite studies. This was done by David Blask from Tulane, great researcher. He does research on animals. So he took 120 what's called the nude rats, and these are not exhibitionist rats. What they are is rats that were bred specifically to accept transplants. So he took these rats and injected human breast cancer under their skin, and then subjected 20 of them each in cohorts. 20 were in the dark at night, and so they had a normal daylight cycle. And you see those white circles going up. That was the rate of the breast cancer growth. Then at the next line over, 0.02 microwatts per centimeter. This is the amount of light that if you live on a rural street and some light shines in your bedroom from the street lamp that's on your corner. That's how low that is, 0.02 microwatts. Look what happened to the breast cancer rate growth, that next line up on those 20 mice. Next, 0.05 microwatts. This is if you're in a more suburb or a city and light shining in your bedroom. That's the same level of light. The breast cancer rate grows faster in those rats until 0.06, 0.08 microwatts, until finally constant light, no sleep for these rats, and the breast cancer rate literally exploded. Okay, great study. Can't do this with human subjects, but I think this demonstrates the issue. Next. So light pollution and cancer. clinical studies demonstrate a significant association between light at night and breast cancer and a modest relationship between light at night and other cancers. And this is on multiple studies. Next. That was a summary study. Go ahead. Buffering the immune system. Study after study shows that the immune system is needed as an immune adjuvant, an immune buffer without melatonin properly reaching its level at night, you're at risk because your T and B cells don't work as well when the melatonin isn't circulating in your bloodstream. That's the hormone that gives them the signal to go out there and kill the bad cells. So if you suppress that just by a little bit, remember I said how we all produce cancer cells every day? If you suppress that just a little bit, don't be surprised if every once in a while one of these bad cells will just sneak through. There's just a slightly higher probability of that happening, which is what we see in all the studies. Next. Again, it's not that light causes cancer, it's the suppression of melatonin that causes cancer. And before anyone asks, taking melatonin pills doesn't prevent it, unfortunately, because it doesn't get into the blood-brain barrier. It has to be produced in your brain in order for it to be effective on your brain. But having said that, there are studies that have come out recently where cancer doctors, oncologists, have used high dose, really therapeutic high dose of melatonin to give with their chemotherapy, and they seem to get a better effect. So if you use a high enough dose, which I'm not advocating, because that will cause, unless you have a cancer and it's life-threatening, this can cause other bad side effects. But in that situation, there is some evidence that it helps. So aging, the cytokines from the cells and T are influenced by melatonin. Again, just another study that shows that. Next. Another study, again, showing the same. I'm not trying to turn you into medical doctors, but I want you to show this isn't just 1 or 2 studies. I'm talking thousands of studies now over the last 30 years that show this exact same thing. This is not unlike lighting companies that may want you were surprised in 2014 that the AMA brought this up. This is real and it's significant, and we should force the lighting companies to not just sell whatever they want, but what we need and not cause harm. First thing in medicine is cause no harm. That's beat into you from day one in medical school. Lighting companies should follow the same mantra. If you're going to put up something on the street, don't put up something that's going to cause harm to you or the environment. Next. Another systematic review of, I think it was 17 studies, all showed the same thing. Dose response meta-analysis performed only in studies investigating outdoor light. Now I'm talking about outdoor light. I can't influence what you do in your own bedroom at night if you put up a light all night long. This is outdoor lights shining in your bedroom. It doesn't take much light to suppress that. Next. So here's one of my favorite studies. I was involved with this one, Nurses Health Study 2. They followed 130,000 women over 20-something years, and they did for multiple health risks. But in particular to lights, they divided these 120,000 women into 5 cohorts using satellite data with the zip codes. So if you lived in an inner city where you have a lot of light pollution shining in your bedroom because you can't help it unless you put blackout curtains, they had a much higher rate of breast cancer than in a rural area where there was no ambient light. Taking all other, and since they studied like 30 different health issues, those were all correlated, and basically this stood out like a sore thumb. And there was 5 different quintiles, and if you went from rural to a little bit of suburban light, to a modest suburban light, to a more intense suburban light, to an inner city, it was just like the study on the rats I showed you, a stepwise increase in human breast cancer. Next. And unless you think that was an outlier, you know, whenever in medicine, whenever a paper comes out and it sounds weird, you say, well, we need more studies to verify. There are now something like 30-something papers. Here's several of them that all demonstrate the same thing. If you live in a light polluted area and you don't have blackout curtains, you basically have and the other paper was about 17% increase in breast cancer. In all these studies, it ranged from 14 to 18% increase in breast cancer, premenopausal mostly, if you're exposed to light shining in your bedroom. Every single one. Israel, US, Connecticut, worldwide study, South Korea. They all said the exact same thing. When you get that many papers saying the exact same thing, it's epidemiologic, but there's no way to do a human experiment by taking a bunch of women, forcing them to sleep in light, and another group of women to not sleep in light. So this is the only way to do that kind of study. You have to do it epidemiologically. Next slide. This is my view of the Veil Nebula. Next. Unless men think they're getting away scot-free, it turns out that if you screw up the melatonin, it affects all hormonally active cancers. Prostate cancer has the same rate of increase in light polluted areas, which is one of the reasons we have an explosion of prostate cancer, I think. Next. Thyroid cancer. This came out of University of Texas, just, was it 2021, American Cancer Society. 55% increase in thyroid cancer if you're exposed to light at night. Next. Pancreatic cancer. This came out of your University of Texas as well. Following 500,000 patients, 27% increase in pancreatic cancers in light polluted areas. Next. This is another study involving diet and health study. And if you're in light polluted area, the odds of getting the obesity is 12 to 19% higher. Next. And by the way, that means you get more diabetes, because if you're more obese, higher rate of diabetes, and that leads to more strokes, more cardiac disease. And the basic rate, though, is increased in light polluted areas. Next. And this is all satellite data. Again, I can't emphasize this enough. I'm talking outdoor lights shining in your bedrooms at night. So Chinese health study did the same thing. Next, metabolic syndrome went up. Cardiometabolic disease in Catalan, which is another marked increase. Next. Heart disease increases in light polluted areas, probably because of the metabolic syndrome. Next. Alzheimer's. This is a study, brand new, 2024, September. Seems to be a direct correlation between bad light at night, shining in your bedroom, and increased rate of, now there's many causes, mind you, but this is another one of the causes, which is easily preventable. Next. Cerebrovascular disease from China. Again, this is worldwide. I'll say basically the same thing. Next. So higher stroke risk. Next. Sleep research. It's Ohio in 2016. If you get a longer sleep at night, you can mitigate some of the effects. Makes sense. Next. Light pollution and excessive illumination on the retina. So we talked about cancers now just very briefly on how it can damage your retina. I don't know if anyone in this audience has macular degeneration. I would hope not, okay? Then you got to stay away. You especially need to stay away from blue lights because it accelerates it. It's not known if it's the cause, but it's well established now that if you're exposed to that 479 nanometer blue light, the macular degeneration accelerates much faster. Next. This is bad for you at night. Next. So LEDs, white that have a lot of blue in it, basically accelerate the macular degeneration and cause actual cell death of the retinal cells. Next. So my view is 6781. It's a great object to look at. Next. And then let's just talk for a moment, and I'll end with just very briefly, because it's not the focus of this talk, of the environmental damage. Everything I just said about how it affects you personally, it affects every mammal on Earth, insects, and multiple other animals. So when we're damaging human health, we're obliterating the environment. Next. And it's the blue scatters quite a bit, by the way. This is from 50 miles. So environmental impacts, it affects plants. Soybeans, farmers have learned that soybeans that are planted near streetlights, they don't produce beans. I don't know why, but they don't. So they stop planting them near streetlights. Decreases crop yields. Insects, we had a talk recently, a few years ago actually, where the person who spoke before me was a researcher from Tufts, entomologist, studier of insects. And his title of his talk was quite telling. It was, "Why is your windshield clean at night?" Okay. 30, 40 years ago, when I drove a car, I'd have to clean the windshield off of dead bugs. People don't have to do that anymore because we've killed them all off. Okay, now some of that, of course, is insecticides, but a lot of it's because the bugs are destroyed by blue lights especially. So right now, the entomologists of the world are in an uproar because they claim 40% of all the world's insects have died. 40%. They're calling it an insect apocalypse. And we need insects for food pollination and for plant growth. We're killing them all off. Fish, sky glow affects invertebrates and vertebrates. And here's a great paper in Nature, January 16, 2018, Travis Loncourt. He is one of the premier environmental researchers from University of Southern California. And this is the last sentence of his paper, which was a pretty long one, where he summarized numerous species that he studied. And his closing statement was, if a lighting environmental effect on a particular species has not yet been documented, it's probably because it's not yet been studied. In every case where studies have been performed, an effect has been determined. And I should add adverse effect. Okay, and since then he's proving, he keeps studying different species and finds the light pollution is affecting them all in a bad way. Next. We all know about turtles in Florida and worldwide as well. On the East Coast, the turtle hatchings were, the turtle population was dying off, and everyone just assumed, again, just like with the breast cancer, it has to be toxins in the environment, bad water, bad air. Well, it turns out someone from the University of Florida finally figured it out. It's all these people buy a house on the water, and the first thing you want to do is put up lights so they can see the waves all night long while they're asleep. And what happens is the turtles hatch, and they're programmed to go to where the light is. So they usually hatch around full moon. The full moon shines in the water, they head for the water, and they're safe. Street light over here, or the light, so that's lights up the beach for no reason whatsoever at 2 in the morning. Instead of hatching and going to the water, they go to the road, never make it to the water, and just die. They passed some laws in the eastern part of Florida where this is occurring, and the turtle population miraculously has come back. But that's just one example. Lightning bugs, worldwide decline, because if the male and female lightning bug can't see each other, you get no baby lightning bugs. Birds are affected, pollinators are affected. Next. The light disrupts the light and dark pattern and for insects and for most animals, and that causes a bad result where it affects predators and prey, it affects pollination. Some things are pollinated only at night. Next. Birds have lower reproductive seasonality if they have bright lights. Insects reduce hormone quality in order to attract each other. Early bud bursts with plants unrelated to temperature, and then the plants die. It just goes on and on and on. Next. So light pollution is a driver of insect declines. Okay, 40% less insects worldwide than 30 years ago. Next. Light pollution is important for agriculture because fortunately most of the crops are in less light polluted areas, but it's if you have bad light pollution, you don't have proper pollination and your crop yield diminishes. Next. Susquehanna River up top. These are mayflies. They're supposed to hatch, mate, and then die and become fish food. Light on the Susquehanna River Bridge. Instead, they just collect under the light. And after this, finally, they replace that light. But that's what was happening. Instead of becoming fish food or making new bugs for the following year, this is what you got. You just have to clean up a huge mess of dead bugs. Next. Here's a great example, just so you realize it affects almost every animal on Earth. So someone in Northern California, some city, thought it would be fantastic if they put up a 4,000 K light under the bridge. Had nothing to do with safety or road safety. Just from the city, you could see the light, the bridge lit up and the water lit up underneath. They thought it was pretty. Salmon used to run up that river. They put up the lights. There used to be 15,000 they counted as salmon. By 2009, after the LEDs were installed, the salmon run in 2011, they had only 800. They basically obliterated the salmon. It turns out the salmon will not cross the bridge if it's lit up underneath. They just swim around in circles, afraid of the light, and just die there and never spawn. Someone figured it out. I wish they would take them down, but they didn't take them down. They just shut them off in the salmon run. The salmon population has come back. Next. Again, species you'd never think about that are affected by lights are affected by lights. Free living birds. If that reduces their melatonin level, they end up having multiple issues. Next. Human food pollination. Birds contribute to pollination as well, and we're killing them all off, basically. And the artificial light is affecting that, and including the migration patterns of birds. We kill 10 to 40 million birds in the US every year. How many people know about in Los Angeles, there is that casino that's a pyramid? You know what I'm talking about?
Las Vegas,
Hmm?
yeah. The Luxor in Las Vegas.
I forget the name of the casino, but it's a big pyramid, and it shines this light straight up into the air. It can be seen by the space. I mean, it's just ridiculously bright light, and you can see it from literally 100 miles away from Las Vegas. It's like a big beam heading up into the sky. Well, here's a little known fact that most people don't realize. That casino has a team that goes out every morning to sweep up all the dead birds that congregate around it at night that should be migrating, and sweep them up before the patrons come in later in the day and see dead birds all over the sidewalk. Okay, and it's all because of that one light. Next. We shouldn't be killing our environment. Here's one pertinent to Florida. Notice we've had a lot of algae blooms and red tide blooms the last few years. Now, a lot of that's because of the sugar industry with excess fertilizer that's going into the stream and ended up on the coast. And that leads to algae blooms. But here's something that you probably didn't realize. What eats plankton? I mean, what eats algae? Plankton. Plankton live about 200 feet down. They come up at night to feed on the algae. If there's even the slightest bit of light shining in the water, they won't come up. They're light averse. So consequently, one of the reasons we're getting worse algae blooms, not just because of the fertilizer, is because the plankton won't come up to eat them. We have a natural predator in our water to help mitigate this, but because of all the bright lights along the coast, our algae blooms are getting worse and worse. Next. Trees. That bottom part of that tree still thinks it's summer because of that light. The rest of the tree thinks it's not and is shed, and that leads to, trees have hormones too, and that leads to stress in the tree. Trees that are near bright lights only live about 2/3 of their natural life. Next. Here's a study from Purdue that basically describes all of that. Next. Yep, typical urban areas with lights and plants. Next. Just want to get, and I just came back from New Zealand. I was happy to be chosen to be a keynote speaker for the Starlight Conference, which happens every 5 years. And I went there. It was a great place, by the way, Bortle 1.5 sky, one of the darkest places I've ever seen. I got the pleasure of observing with the head of Mount John's Observatory at his home. Anyways, next. The one I'm not going to, that's a whole nother talk. Here's the Mount John's Observatory. It's a fantastic place. Next. But while I was there, well, next slide. These are just pictures. There was a European Union lawyer who made a presentation about light pollution laws taking effect or have taken effect in Europe. They're way ahead of us. Everything in purple has passed laws. Some, not the whole country, some just regions, but they're basically, and the rest in light purple have laws about to be passed. They're being worked on. Basically, the European Union is on board, except Belgium, where Siemens is located. If you notice, that's a standout. Siemens is based there, and they keep buying out the politicians, so they won't pass those laws. If you look at light pollution laws, the brightest place on earth is Belgium, and I wonder why. They just have a ridiculous amount of street lighting. But so they're passing all these laws. Next. And I copied some of her slides. These want to be countrywide light pollution laws. France wants to go one step further. The others just want to limit it. France law says that they're just about to sign and pass, says we don't just want to limit it, we want to cut it by 50% over the next 8 years. That's amazing, first country to do that. So they're going to basically get light pollution back to 1990 levels, and that's their goal. Next, I wish the US would do that. I was involved with the UN committee, Kupus and Dark and Quiet Skies for Science and Society. That I wrote the part of it on human health, and that's downloadable. It's 297 pages. It deals with a lot of things. My section is not that long. Next. And it deals with a number of things, but the Europeans, again, are fully on board on controlling this problem. Next. My view of Saturn. Next. And, you know, where I live, it's a rural, it's about a Bortle 4. Here in Florida, I'd say it's, for most of you, it's Bortle 7. It's just, that's all I'm going to say about it. I think for that reason alone, you should want to control the light pollution here. Next. Number of stars. At Bortle 7, which is, you're down to about third magnitude or less. You only see 190 stars in the sky. You should be seeing 6,000. Next. Here's the paper on dark and quiet skies. It's a great summary from people all over the world. Next. I was there, my name's up there, but basically these are all the people worldwide who contributed. It passed, it's sitting in front of the UN, and hopefully when all these wars end and they can deal with this, they may pass some regulations. Next, guidelines. Can't pass regulation. Responsible outdoor lighting at night. This was a European initiative. I was involved with them on this, and they're really going gung-ho on controlling light pollution. Next. Here's that paper that I just wrote. You can download this. Are you going to make it available for people to download from the website?
I'll send it to Mike so he can get on the website.
And again, you can get a CME credit if you read it, but this basically summarizes with references everything I just told you tonight. Next. So I'll stop there. And if you go to my website, mariomattamd.com, ignore the AMA stuff and go to light pollution or astronomy stuff, and you can download everything I just showed you. All right, any questions? Yeah. Complain, complain, complain. How did all these other states start? Basically, citizens saying, this is ridiculous. Stop doing this to us. You don't realize it until you live under 4,000 K lights, how intrusive they are. I mean, even New York City, which is incredibly light polluted, the people couldn't stand it. Okay, these 4,000 K lights are bad for driving. Okay, blind you. Come in your bedroom, light up your bedroom. I mean, if you can see stuff in your bed at night, that's way overlit. Okay, if you got no other option, get what's called light blocking curtains so that you can actually get a safer sleep. But my view of this is these are tax support. I can't tell you what to do in your own bedroom. That's your choice. But we should demand that anything's put up with tax dollars on the street shouldn't be harmful to human health and shouldn't be harmful to the environment. That's a demand we can make. Okay? No, the AMA won't do that. It's not a lobbying organization. It's a tax exempt. So you have to do that yourself. But you can download the material from my website and you can use that to help you. Yes. What's that? Yeah, that'll help a little bit. But again, why do you need that at night in your own bedroom? Well, I mean, think about it, how silly it is. The third worst state is Texas. They're anti-regulation, and Houston is one of the worst lit cities in the entire world. You can't drive in Houston at night. I know people in Houston that basically wear these. I mean, they sell them now. They're blue blockers at night so you can drive. How insane are we that we're putting up lights that you have to wear basically sunglasses to drive at night? Think about how insane that is. Yeah. I can't hear you.
Here. Is it, is the effect more profound with, like higher than 27K lights?
Yes.
So if they went down to say like 27K, how much of an improvement would we see?
Any blue light suppresses. 4,000 K lights are about 32 to 35% blue. 3,000 K lights are about 21% blue. And 2,700 drops all the way to 15% blue. Now, there's another solution in Quebec. They went one step better. They went to amber-based lights. Instead of that blue light, they use amber lights for all of southern Quebec. The reason is because they had an observatory that they wanted to protect. And Sherbrooke, they went to the town, Sherbrooke said, can we replace all the lights with amber-based lights? There's no blue whatsoever, okay? Zero blue. So they convinced the town. I should have put pictures of that, but the lighting is great, absolutely great. You can see well. It's slightly orangey tint, but the colors are fine and you can see well. They even went to the farmers and dairy herd farmers and barns, took off their bad lights, the typical wall pack security lights, and put up amber lights for the barn. You know what happened? First, the farmers were resistant. The cows produce 20% more milk when they're not exposed to 4,000 K lights. So the farmers are tickled pink. They're getting good lights, which they got for free from the government. They get 20% more milk production out of their cows, and they're not destroying the environment. Win-win-win situation for everyone.
I have one more question. What, is there anything in place to reduce the headlight problem that we're having now? Because
That's a
unbelievable.
whole nother issue, the headlights. Remember Newt Gingrich, when he was Speaker of the House under Clinton? That's when the Republicans went totally nuts and wanted to eliminate all regulations. Everything had to be, everyone's fends for themselves, get rid of all regulations that protect us. So back then, the auto companies didn't want regulations. He bent to their will, and they passed a law that took headlights out of the Department of Transportation and basically put it in an obscure committee that hardly ever meets. And basically, the auto companies are self-regulated at this point. That's why they can put up these ridiculous lights, because there's no one to tell them, no, you can't do that. And that's not going to change unless they change. And we're not going to get into politics, but it's not going to change in the next 4 years.
Are there any questions from the group online? Okay. Any other questions here? All right. Well, thank you, Mario. Very, very interesting talk.
Thank you.